In this presentation, I will discuss the following topics in relation to climate change. Conventional and biodegradable plastics, the toxicity imposed on the oceans and marine life, possible alternatives to plastic, innovative reuse measures, and reduction of greenhouse gases. As Edie states in a 2019 article, Climate Change Drowned Out by Plastic, the problem with solving climate change is that it requires collective and institutional changes to make meaningful impacts. The invention of plastic and its lightweight, strong, durable, and corrosion-resistant abilities became a major part of everyday life. Typically, biodegradable plastics are made from renewable raw materials such as starch or cellulose, rather than the conventional plastics which are derived from crude oil. However, there is still a debate as to whether bio-based materials are actually environmentally friendly in comparison to conventional plastics. In some cases, the lack of consistent evidence of biodegradable materials' composability and misleading claims may inadvertently promote littering behavior. A study of 2 OXO biodegradable bags, OXO meaning pro-oxidant, an additive intended to promote biodegradation, were submerged in a marine life environment on the left and buried in soil on the right for 3 years. Following the experiment, each still sustaining their structure well enough to hold 5 pounds. In a 2015 study, solid waste, population density, and economic status were analyzed, estimating the mass of land-based plastics entering the ocean. Of the 275 million metric tons of plastic waste generated in 192 coastal countries in 2010, 4.8 to 12.7 million metric tons ended up in the ocean. The map depicts the estimated mass of mismanaged plastic waste in millions of metric tons generated in 2010 by populations living within 500 kilometers of the coast. The second image depicts the fragmentation and leaching of a plastic item to microscopic plastic parts, microplastic, nanoplastic, oligomers, and chemical fragments as a result of diverse stresses from weathering in the marine environment, such as UV radiation, biofilm formation, and physical stress through turbulence. It has been proposed that microplastic could physically block the gut, gills, or feeding appendages of fish, zooplankton, and other invertebrates, causing decreased rates of growth and possibly starvation and death. A 2014 study estimated more than 5 trillion plastic pieces weighing more than 250,000 tons float atop the ocean's surface. Small pieces make up majority by count, but large items account for the greatest weight. Ocean currents cause plastic to accumulate in the North Pacific and North Atlantic, also known as garbage patches. Studies have shown that in a plastic-laced marine environment, organisms had poor quality egg and sperm, produced fewer larvae, and the larvae in which consumed the microplastic had a decreased growth rate and failed to respond to the odor of predators. With glass being a renewable source that isn't made up of chemicals, but rather sand, there isn't the risk of leaching. Glass bottles are 100% recyclable and require less energy to produce new glass. In an assessment of the full life cycle, glass containers proved to have the smallest carbon footprint. However, though the reusability of glass is beneficial, the recyclability in some regions is economically unfeasible. Another alternative to plastic is a solid material left over after grapes have been pressed during the extraction process in the winemaking industry. Vigia, an Italian company, has used grape waste to make synthetic leather, apparel such as dresses, shoes, and bags and could soon acquire the capacity to manufacture furniture and automobiles made with grape waste. Most commodity plastics have gross calorific values comparable to or higher than that of coal. It is argued that petrochemical carbon, which has already had one high value use when used again as fuel in incineration, represents a more eco-efficient option than burning the oil directly. In Brown's 2015 article, Dirty Plastic, she argues using plastic for energy would mean leaving a portion of the fossil reserve in the ground, ultimately saving extraction costs and energy. The Blessed machine, as previously shown, designed for plastic to oil processing through thermochemical decomposition, can produce 1 liter of oil for every kilogram of plastic. In more advanced models, it can process 240 kilograms of plastic per day. That's enough to heat 70 homes with almost no waste byproduct. This process produces approximately 78% less CO2 emissions than incineration and 83% less than plastic recycling. A circular economy is an alternative to the traditional linear model of make, use, and dispose. This keeps resources in use for as long as possible by extracting the maximum value, recovering, and then regenerating the materials. For over 10 years, China has studied the implementation of a circular economy through the Chinese Plastic Recycling Industries, CPRI, and whether these policies could be used on a global scale to combat greenhouse gas emissions. As a result, CO2 emissions reduction increased from 7.67 metric tons in 2007 to 14.57 metric tons in 2016. From the findings, and with the technological development in the CPRI and the growing trend of substituting steel, aluminum, and other energy-intensive metals with high-grade recovered plastics, the potential of greenhouse gas emissions reduction will be significant in the future.